All right, so now we're officially recording. And then obviously, if you take value from these meetings, we are meeting on a monthly basis, typically the first Monday of the month, unless it falls on a holiday, where actually we meet the second Monday of the month typically. But if you get value, I hope you get a lot of value from these meetings, from our group in general. Spread the word, get involved. As far as the involvement, I'm always looking for speakers. If you know somebody who wants to present, who's a good speaker, let me know. Jobs. Typically at this time, I give the opportunity if someone has any job openings around Microsoft BI to let us know, either by kind of unmuting your microphone and telling us about what you've got, or putting this the notice in the chat window. So does anybody have any job openings that you would like to advertise?
Hey, Teo, thanks. This is Preston Basarvi. I'm with Improving. We're a local Atlanta Microsoft consulting firm. We are looking to extend our data team. I'll go ahead and put some information in the chat window, but yeah, we're looking for predominantly Microsoft Stack BI and data engineers.
Sure.
Thanks, Teo.
Improving, previously known as Innovative Architects, is one of the top consulting companies in Atlanta. So definitely something that probably should inspire interest if you're looking for a career change. Anybody else? Anybody else who has any job openings looking for BI talent? Guess not. On the event side of things, a couple of things that I would like to bring to your attention. The Atlanta Code Camp is on October 9. This is kind of developer-oriented event, but I don't know what kind of audience we have here. Might want to tell your coworkers about it. Pretty much they cover Microsoft developer technologies. And then we have Microsoft Ignite coming on November 2nd to 4th. Microsoft Ignite is the premium Microsoft conference. It's a 3-day conference covering pretty much everything around Microsoft, not just BI. Definitely, I wouldn't imagine they wouldn't have any kind of a free sessions, or, since everything became virtual, a lot of that stuff, a lot of these sessions are available for free, but probably they would like you to sign up to register, and then maybe they will give you access to the free content. Definitely something to check out. Does anybody have any other events worth mentioning that are happening, I guess in close to where we are?
Yeah, PASS Summit is happening between November 8th through 12th online. So it's a free online conference, the same exact conference that every year has been in Seattle and other places. This year is going to be virtual too. So
November 8th to 9, yeah. Is that what you said, Damo?
Yes, November 8th to 12th.
To 12th,
yeah,
all week. Wow, that's definitely, I should remember to put it the next time.
So I'll just put the link in the chat window.
Is it, you said it's complimentary. Last year, I don't think it was. Are you sure
Last
it's
year was not. Yes, it is free this year. Yep.
Free this year. Great. Wow. A lot of freebies.
Even the pre-cons are only $200. It's not expensive at all. So it's going to be a good this thing.
Awesome.
I put the link on the chat window. So
sure. Anybody else knowing about anything going on in the community worth mentioning? It's not. So we're gonna keep on going then. On some interesting things that caught my attention since our last meeting back in September. In fact, today, Microsoft announced the general availability just now of the next generation Power BI. I would appreciate if you guys mute yourself. There's some background noise, unless you want to speak. Thank you so much. So today they announced the general availability of next generation premium platform. If you are using Power BI Premium, definitely you should actually switch to it. We talked before what the next generation is, but I can tell you from experience that by just churning one little switch to the next generation premium, the performance, at least of one client, actually greatly improved. So you're not paying anything more if you're on Power BI Premium. You just have to go, you have to tell your Power BI administrator to go to the capacity, make that switch from off and on, and then lots of good things actually will happen. Hopefully your performance will improve because there are, quite a bit of infrastructure there to make things faster and better. We have a feature in preview called Get Insights that I'm going to demonstrate in a moment because it's better to see it than tell you what it does. And there's another on the Power BI goal size of things. The last time I talked about goals, when I actually did a small demo, I said that one of the biggest issues that I had with goals is that the statuses were not dynamic. You have to manually go and check in to change the status. But now we have the introduction, and basically Microsoft introduced this rule-based statuses that I'm going to show you in a moment. And on the SSRS/paginated report side of things, we have a new version of Power BI Report Builder, which is the tool for building, one of the tools actually to build paginated reports. And also we have a new version of Power BI Report Server if you're using this on-prem instead of deploying to Power BI service. So quickly kind of announcing this meeting. So on this, not October 14, apologize for that. It's actually October 4th. So the main presentation is going to be Power BI modeling. Reza Rad is going to do it in a moment. Our next meeting is going to be November 1st, where we're going to have Sandeep Pawar coming in and telling us about the Power BI AI visuals. So there's a lot of stuff happening in Power BI around artificial intelligence. So he's going to be actually talking about those Power BI visuals and how you can use them to implement very easy, no code AI in your company. That's what I have to say. I'd like just to show you a little bit about these two features that I mentioned: the Get Insights and the and Goals. So both features are Power BI premium features. So this is another kind of a premium teaser here. Well, let's take a look at see how they work. So I'm in Power BI Premium. As you can see, we have this diamond indicator that tells us this is a premium workspace. So I'm going to go to a report that I have here, which we implement during the Power BI Dashboard in a Day training. And we have right there, we have a button called Get Insights. So many of you are probably familiar in the past with Get Quick Insights at the dataset level, the dashboard level. So now we have it actually at the report level, and Microsoft actually did quite a bit of work to make this nicer. So in fact, for me, it's not happening for some reason. But if your users open a report, then Power BI automatically is going to try to get some insights. And if it finds some interesting insights, it's going to pop up a message saying that there are some interesting insights about this report. But the user can also always click on Get Insights to manually initiate the process. And then Power BI is going to apply machine learning to figure out if there are some interesting trends. So it discovers things like trends, KPI analysis, and the documentation goes in more detail about how these things work. It gives you a summary, kind of narrative also about what it found. And if I want to look a little bit more, about, for example, here we have that there is a recent trend in revenue. And it tells us that this company, one of our competitors actually, started trending up on 2016. So these insights in the past, one of the issues that I have with quick insights was that some of these insights were actually really very, you can tell they're machine generated because they really don't make any sense. There could be some useful ones, but it looks like what they did now, actually these insights become much more intelligent that actually could really inspire some interest. So as you can see, the first one, the second one, revenue for Purim jump from here to there. Definitely is worth exploring. So if I click on it, I get a line chart. I've got some explanations also why potentially this could have happened. So we see this this big spike in here. And here we have some context that tell us that extreme, which probably is one of the segments, product segments or whatever, accounted for the majority of the increase for this company. So without you doing much about creating mining models and stuff like that, just with the click of a button, you have this insights generated for you. So definitely check this out. I think your users might be delighted. The second thing that I wanted to share with you is on the Power BI goals side of things. So a while back, when I first talked about Power BI goals, I mentioned that Microsoft wants to democratize goals, just like it's democratizing BI. So it's very common that every company would like to see, have some goals or KPIs. They want to track some things and compare them against some target or something like that. So we had that feature, on the professional side of things. We had a feature called KPI, which was built in our services, and it's available even today, although there is no UI in Power BI Desktop to take advantage of that feature. You have to use community tools like Tabular Editor to let you define KPIs in your Power BI data set. But Microsoft wanted to make that even easier to use. So if you're on Power BI Premium, you're going to see that menu here where users can actually create their own scorecards. So for example, here I have a scorecard that I've created real quick where I'm tracking two goals. The first one is customer base. And without going too much in details, there are two ways to create goals. The first way is to manually specify the actual value and the progress, right? So you kind of type the number. If this is not a data-driven, but you have some other ways to calculate this, you can go here and you can publish it so other people can see it. But the second way, which is more exciting, is the data-driven goals, like this revenue that I created by combining for actuals. I went to a report, and by the way, if I click this button here, the report indicator basically is going to tell you which report this goal came from. Basically, what I did here is I chose one of these line charts. I chose a value to map it to my actuals. Now, for one of the caveats, as I mentioned before, is that what about the progress? Actually, I'm sorry, the status. The status previously you had to actually edit the goal to manually change the status. It wasn't data driven. But now, if I go to the edit mode, and if I go and click that goal, now what I can see is that we have on the status field, we have also rules. So this is very similar to data alerts. If you have used that data alerts feature, which is available in Power BI dashboard tiles, it's kind of similar thing. I can go to my rules and I can say if the actual value is, let's say, greater or equal than 100% of the target, then we are on track. Otherwise, we are at risk. So the bottom line, the takeaway here is that now this status is not only the actual in the target, but also the status could be data-driven. You can create rules, and these rules are very basic. Is less than or equal to, equals to, greater than, so forth. You specify there are some predefined fields here that you can choose from. Very easy to create. Again, this feature targets business users, somebody who probably even not go closer to Power BI desktop to create KPIs, measures, and stuff like that. Just want to make it very easy for them to create goals by combining measures from different reports so that we can track it across the enterprise. Any questions? About what I showed you, what I covered so far? Any questions in general? Does anybody have any questions? I hear some noise.
I didn't understand where you got the goals. I mean, I saw you got it from a chart, another report, but that didn't
Sure.
seem very obvious.
Sure.
Normally we would do something like say, we want to do 30% better than we did last year and use that as a goal, but you seem to be doing a lot more.
Yeah, so let's go and create one real quick. So let's go and call it Atlanta BI here. So as I said, there are two ways to define the current and the target. I can hard code the value, or I can make it data driven. So I'm going to actually click on this connect to data. And what it's going to do at this point is going to say, okay, here is the reports you have access to. Now let's go and find which report this actual value is going to come from. So I can go, let's say, to this first report, and here Power BI is going to show me what this report looks like. So here I have to go and actually figure out what visualization. So this is kind of interesting. Initially, when I saw that, how Microsoft implemented this was a little bit like, why they did that? Why the goal should be coming, the actual should be coming from reports instead of creating a measure. And again, the reason for this is that they wanted to make it very easy. Reports are already published there. Different people that know what they're doing, they have these reports. So now I'm a business user, I want to track things. I really don't know how to create measures and use DAX, but I do know what these reports mean. So what I can do, I can say, okay, well, this report here, this visual here, the line chart shows revenue by year and manufacturer. So what I can do, I can choose a data point in that visual. So I just click on that data point, and then Power BI is going to say, okay, for actual, what we're going to do, here is the context of that data point that you clicked. Here is the latest value in that chart. And, at that point, I can just go, and actually click connect. And this is how we actually establish the connection. This is how this current value is going to be generated. And of course, when the data changes behind the report, when the report refreshes and the data set refreshes, then this value also will change. It's kind of a data driven, right? And I can do the same thing for the target. So this is how it works. And if I click update connection, actually, it doesn't show me where this came from exactly. So I have to go and repeat the whole thing. But that's how it is. Make sense now?
Thanks.
Any other questions?
Would that be taking the most recent month, or you would have to change it each month?
No, it's going to take. So there is if you maybe notice when I went to this report, there were two options there. There were a few options. And when I selected that point in here, it says that track all data in this time series. So there are two options. If I select track this data point, then it's going to track only that data point. Obviously, so that's going to be for this month, for that filter. If the data refreshes, if the data changes, obviously it's going to update it. If I select track all data in this time series, what's going to happen is going to be kind of dynamic, depending on the context. It's always going to take, because here it tells you it's from 1st of January until 31st of December 2020. If there is a new month with data or new day with data, depends on what you're plotting on the chart, then Power BI is going to detect this, and now the last point is going to become the last day with data.
Makes sense. Thanks.
Great. Well, kind of on top of the hour. Without further ado, I'm going to introduce Reza Rad, who is our main presenter today. He's going to tell us about Power BI 101 modeling. Reza, the floor is yours.
Great, thank you. Appreciate that. And great presentation as well.
Thank you, Reza.
Okay, right. Let me go to the slideshow from current slide. Great. Can you see my slide?
Yes, we can.
Okay, great. I'll bring Teams window on my other screen as well, just see if there's anything on the chat window. Okay. Thank you everyone for joining this session. I'm very glad to be with you. This is a session about Power BI modeling, very basic concepts. We are not talking about advanced modeling scenarios. So some very basic examples of why we need relationship, what is relationship, and things around it. It is so good to be with you here. And as a coincidence, actually, like almost 2 years ago, I've been in Atlanta. Actually, we had the SQL Saturday BI edition 2019 that time. And it was fun time. So fingers crossed it happens again, and we come back over there. Loved the city, loved the people, loved everything. So a little bit about me. I'm Reza Rad. I work at RADACAD. I'm a Microsoft MVP and regional director. I've written some books on Power BI. Some of them you can find it in our website. There's a section of books that you can find the links to all books. Some of them are free available, like Power BI from Rookie to Rockstar. You can download it and read it. I also have a lot of Power BI video courses as well, which you can check that in our Academy website. Or if you are looking for some free videos, we have frequent videos like weekly, basically, in our YouTube channel and our blog. We have a lot of free materials over there as well. So jumping into the topic and starting with the relationship. Now, Power BI relationships and database relationships are a little bit different. If you are coming from database background, you already have understanding of what the relationship is. That understanding is good to start with Power BI, but you still need a little bit more than that, because Power BI relationship is slightly different. If you don't have any understanding of what the relationship is, I have a very quick intro to that in this section as well. So what is a relationship? Imagine we have a table, stores table, which has some columns in it, and we are going to visualize it in a simple bar chart like this. So here I have state as the axis of my chart, and count of stores as the value. So you can see that it slice and dice beautifully. I can see, for example, in California, I have three stores. In Washington, I have 2. In Oregon, just 1. How it works is that this table, this is the table that has the data, actually gets filtered by the value used in the axis of this chart. In this case, that value is state. So the table gets filtered for all records that their state is similar. For example, Washington states California, and Oregon. I changed them based on the color so you can actually find that. So we have 2 records for Washington, 3 for California, 1 for Oregon. So it works really nice and really simple. There is no relationship in this case, it's just one table. This table can be also like another table. For example, here I have a table that I use store ID. This is a table visual. Store ID is the field that slice and dice the value that we have here, which is quantity. So what happens is that, for example, for one store, like for example, 7066, we have 2 records. The quantity of those 2 will be added together and we'll see 125 here, right? So everything in one table, nothing really complicated, very simple. Now the situation changes if we have values coming from 2 different tables. Now, in this case, I have a sales table and a stores table. The table visual that I have here has state from the stores table, because the state is a field in there. The quantity, however, comes from the sales table. And what you see is that the quantity is 493 regardless of the state we are in, and in total is also 493. So if we look at the data of these tables, this is stores table. In the stores table, we have store ID, name, city, and state. So state is the field that used in this visual. In the other table, which is the sales table, we have the quantity. But the fact is that these 2 tables don't talk with each other. There is no way that the quantity gets filtered by the selection of state, unless we find a common field that we can actually look up one in the other one, right? In this case, that field can be the store ID. For example, what we can do is that we can find one store based on the state. Let's say, for example, in California state, we have one store here, 7066. And then look that up in the other table for all the records that 7066 is the store ID. What is the quantity, right? This action can be done simply by a relationship. What we do is we define a relationship between these 2 tables. We create a relationship between the store ID of one table to the store ID of another table. And that relationship will give us a way to filter this data. Once that relationship is created, that means this table,
you want something to eat?
Stores table
outside.
can filter the sales table. And here is the result of that. So the relationship is created based on store ID. It's not based on state, or it's not based on quantity. But that relationship means that, for example, when we look at one state, Washington, for example, there are 2 records for that. Each record has its own store ID. Then that store ID will be looked here. And then the result of that will appear here. So that relationship gives us the ability to slice and dice, a value in our sales table by any field in the store table. That is what the relationship means in Power BI. It means filtering. Now this is basic. I'm going through that just with slides. But whenever you have a question, just feel free to let me know in the chat window or just ask your question. Another important property of a relationship is the cardinality of the relationship. Cardinality of the relationship basically means that one or many star, basically, you see the relationship. Sometimes it's the other way around. It's one side is star, another is one. Sometimes it's 1 to 1. There are actually 4 types of relationships and many to many, right? These 4 types of relationships are basically saying how the cardinality of that value is in each table. Taking that store example again. So we have the stores table here, and we have the sales table in the other one. The store table, if we look at every record has a unique store ID. So store ID, sorry, clicked wrong time. Store ID has basically 6 unique values. When you click on a field in Power BI Desktop, it tells you that actually how many distinct values you have, which is unique values. So we have 6 rows and we have 6 unique values in store ID. It's kind of like store ID is the unique field that based on that we can find which store it is. In database definition, we call this key a primary key. And that store ID, however, in the store table have multiple instances of one value. For example, for one store, we have multiple sales transaction, and it is absolutely fine. So in sales table, I have 21 rows, but the store ID is still 6 unique values. So if when I create a relationship based on store ID between these two fields, let's say the side that has unique values will become one side of the relationship. The side that has multiple values will become many side of the relationship. This is a definition of one to many. And we have 4 types of relationship, as I said, one to many, many to one. These two basically are the same thing. It's just a matter of which way you read the relationship. One to one is a quite common type of relationship when you have like master detail, but still at one row. For example, you have customer in one table, customer phone number in another table, considering that each customer just have one phone number in that scenario. Many to many relationship is a relationship that would require a little bit more discussion, so I'll get back to this a little bit later. So everything that I told you so far is common between database relationships and Power BI relationships, but what are different? One of the differences, one of the specific unique features of Power BI relationships is something we call active or inactive. This is an attribute in a Power BI relationship, that a relationship can become active or inactive. By default, relationships are active unless there is no way to create that relationship as an active. So I'm going to show you this as a simple demo. I have a Power BI file here, and I'm going to get data from sample Excel file. This AdventureWorks data warehouse example, you can download it from my blog as well. There's an Excel file version of that, or you can download it from SQL Server AdventureWorks example. So what I'm going to do is I'm going to select table, date table, let's say, and the fact internet sales table itself. I'm loading that data into Power BI. Before loading it, just to let you know that in fact internet sales, I have 3 date fields, and they are totally different types of date related fields. One of them is about order date, another is due date, another is ship date. I want to be able to build a visualization or build a report, build a dashboard that I can slice and dice by any of these dates, by the date attributes of any of these dates. So I'll bring a date table, which has all the date attributes in it, such as the weekday name, the quarter, month, anything I have, and I'll bring the fact internet sales itself. I'll load that data into Power BI. Now, Power BI has this very helpful option, which is detecting the relationship. It automatically detects the relationship, but what I'm going to do is just to remove that relationship and show you how it can be created in a second. So I'm going to, yeah, it didn't create a relationship, so that's a good thing. I'm going to first disable the auto date time here, just so that it avoids automatic creation of a date table. Okay, so I have my sales table and I have my date table. These 2 tables are here. I'm going to connect them using a date field. Now, one of the ways that we use a lot in data warehousing scenarios is that our fact tables, they might not have an actual date field. They might have something, we call it a date key. Date key is something like a 8-digit 8-character actually number, which the first 4 characters are year, then 2 characters for month, 2 characters for day. You may have this structure, or you may have an actual date field. In this case, we have both, so I can use either order date or order date key, one of them to connect to my date table, because date table also have the date key, or alternate date key, which would match to the order date. In this case, I'm going to use the order date key. To create a relationship between one table and another table, you can just simply drag and drop a field to the equivalent of that field in the other table. That basically creates a relationship, right? And it doesn't matter, did you like drag and drop field from this table to that table or that table to this table. So it creates the relationship, and I hover on it. It shows me what are the fields participating in these relationships. You see that fields. It also has the cardinality of relationship. One to many means that the date key in dim date is a unique field, has unique values per row, but the fact internet sales, we have multiple instances of one date because there has been more than one sales transaction in that date. This gives me the ability to go to a report and build visualizations like this. For example, having sales amount from the fact table, and from dim date, I can bring something such as calendar year. So it works just fine. So when I look at this visual, it shows me, for example, 2007, these are the sales transactions that their order date year has been 2007. The reason for that is that this connection is a connection to the order date. Now, what if I want to build a report saying that show me the sum of sales for all of those that their ship date, because we also have a ship date, or their due date, there's another field called due date, those have been, let's say, on the 2007 or something like that. So this basically means that you perhaps need to create another relationship. And if you go and create another relationship between date key to the ship date key this time, the second relationship would be a little bit different. You see, this is a dashed line compared to the previous one, which is a solid line. We call this one inactive relationship. Inactive relationship is not participating in any filter. I go to.
Good. I'm just tired. But
I think one of the
Somebody might want to
microphones.
mute.
Yeah,
If I go to the.
I muted. Yeah, sorry about this, Reza.
Oh, that's okay. So if I go to this visual, I'm still looking at data sliced and diced by order date key because the active relationship is order date key. So Power BI always just having an inactive relationship is not doing anything special unless you go and write a specific measure. There's a DAX function you can use called use relationship. So unless you go and use that and write a specific measure saying that calculate sum of sales amount, use relationship, this one, the inactive one, it is not going to do anything special. So what I'm going to do is to define it in another way. I'll delete this relationship, the inactive one. What I need to do is I need to have, basically you can have one active relationship between two tables. You cannot have more than that. So as long as I have just these two tables, I cannot have more than one active relationship. What I can do instead is to create a copy of this table and then create a relationship based on that. This is a very common scenario in BI systems. We call it a role-playing dimension. You can create that copy in Power Query. You can create that copy in, let's say, database by creating views. One of the best places, however, for that copy would be doing it here as a new table in Power BI. This is a calculated table, and I can create a table saying that, for example, ship date. This is DAX. Ship date is equal to all dim date. This is basically just a copy of dim date. It is not. It is unfiltered copy of dim date. That is what this all does. It gives me a copy of that table with all columns, all rows, nothing filtered, right? And you see it is actually with all of those columns. This shows you that this is a calculated table. Now, once this table is created, I can go to the model and I can create a relationship this time based on the date key and ship date key. And this would be totally active relationship. You see, this is based on ship date key. The other one is based on order date key, which is a little bit higher, right? Now, it is much better if I also rename this and call it order date rather than just div date, because that is what this table now is. So this is order date, ship date. I can have another copy of date table and I call it due date and I create a relationship. This works perfectly fine. We call this solution a role playing dimension. One dimension play roles of multiple dimension. It's one date table, but sometimes it is order date, sometimes it is ship date, sometimes it is due date. One of the questions I get a lot when talking about this is that, well, isn't this copying of the data? Is it a good advice to do that? Like, for example, we are creating an exact copy of the date table here. Is it a good idea to do that? It really depends on the size of your table. If it is date table, let's say date table, it's like 365 records per year. For example, in your analysis, you perhaps just have like maximum 20 years of data. That is like 7,000 rows. 7,000 rows, creating a copy of that is not a big deal. Even if you create like 10 copies of that, it's not a big problem compared to a fact table, which might be millions of rows. Date table is so small, so tiny. So in those situations, I would say, well, copy that table. It wouldn't hurt. But if you are talking about a big table, for example, you have a customer table, and you want to create a role-playing dimension of your customer table. Your customer table, let's say, is 10 million rows. In that case, I wouldn't create that relationship. I would keep that as inactive relationship, but then use that DAX function, use relationship to work with that inactive one. So it is really depending on what you want to do. Now, with this situation, if I want to analyze something based on ship date, I can create another visual. Let's say this time I create a table visual with bringing sales amount from fact internet sales, and from ship date I'll bring calendar year. Just to show you that these two are different values, I also convert this to a table so that you can see that they are actually different values. So in fact, I can slice and dice these separately. But one situation is that if you want to have both in one visual, like you want to have one calendar year to filter based on order date and based on ship date, that is again another situation that it's better to keep inactive relationship rather than keeping that as role playing. So it depends on the situation that is different. So what I explained here was the concept of active or inactive relationship, which we don't have it in normal relational databases. It's something special for Power BI, or in fact, let's say for analysis services tabular model, because Power BI is based on that. Now, another important factor of the relationship attribute of the relationship is the directional relationship, which is, I would say, the most important attribute of the relationship. A lot of bad modeling practices happens because of not understanding how this exactly works. The direction of relationship is a really important factor in the way that data filters in Power BI. Now, again, I'm going to show you that as the example. So going back to this example, I have sales and these two date table. I'm going to add a couple of other tables. So going back to my data source, this time I'm bringing customer table and product table and load. So this should this time automatically detect the relationship of these two. Yep, here it is. So I'll bring them in here. Okay, so product table and customer table. Customer table is related based on the customer key. Product table is based on the product key. So they are all connected. In fact, we don't have a table here not connected. If I go and do a visualization, let's say based on like a simple table visual. In this table visual, I say, give me, for example, the education, which is a field from customer table, and then sales amount, which is a field from fact internet sales. Slicing and dicing works perfectly fine. Let me just make these font sizes a bit bigger so that you can see these easier. This is one simple way to make font size bigger across all of your visuals. You come to the theme and change the font size, and it changes everywhere in all of your visuals. So here I have this slicing and dicing works perfectly fine. 29 million is the total sales, and for each education category we have different sales value, and that is working because of this relationship. Because whenever I select education is a field in customer table because there's a relationship between these two tables based on the customer key. So that means this table actually filters that table, and then from this table I can get the sales amount, which is a field somewhere here. I don't have it right now, but that dollar value comes from this table. This works perfectly fine. But what if I want to do something a little bit different? Let's say I want to get count of products sold for each education category, right? Now, count of products, I can get it from this table because I have product key, I have product number, I have actually everything here. So I'm going to choose a field from here and convert it to become a count so that I get the count of product for every education category, and they are all related. When I come to my visualization, let's say I'll remove the sales amount this time. From the product table, I bring any field. It wouldn't really matter because I want to change it to the count. Let's say I bring product key and then change it to be count. This is a way that you can actually get the count of rows from a table, bring a field from that table, and then change that aggregation to be count. So I'll change it to count. Now what you see here is that this generates something like this, count of product key, which in fact it is count of products. For every education category, it looks 606. And in total, we also have 606 products. So it doesn't really look correct. In total, it's 606. And for each English education, it is also 606. It looks like that this doesn't really filter that. It looks like that this filtering doesn't work. There is something blocking this filtering. Let's look at the relationship diagram again. So all the tables are connected. There is no disconnect in these tables. I'm going to show you that in these tables because the date tables aren't really doing anything in this visual. So zooming in this section, I have the English education in here, of course. Count of product key comes from this table. So what it means that I want this table to filter that table. The direction of relationship means filtering. Here you see direction of relationship is from customer table to fact internet sales table. This means that this table can filter that table. Direction of relationship from product to sales means this table can filter this table, but it doesn't mean the other way around. Here I'm trying to filter data towards product table, not from the product table. So this is not supported. This is supported. I can filter this way, but I cannot filter this way because direction of relationship doesn't support that. Direction of relationship says only when you select a field from the product, I filter the data of the sales table. That is the meaning of direction of relationship. Now, let's go back to this example and say, well, how we are going to fix it. One quick way and common way is I can go and change this to become both directional relationship, meaning that then it would filter this way and that way at the same time. That is by just double clicking on the relationship, changing cross filter direction from single to both. Let's say I do that. I click on OK. This looks like a both directional relationship now, even if it is one to many, but it is both directional. Now it means it can filter this way and it can filter this way. And this one is already filtering this way relationship. So this means that a filtering approach like this would work because this is supported and this is supported, right? And if I go back to visual, everything looks fine. It filters the data correctly. So for each of these English education, I have data sliced and diced, and in total I have 606 records. This is the meaning of direction of relationship, means which way the filter propagates. For this way, for this, both directional. Now, when we come to this stage, a very important question is that, well, if this is good, if both directional relationship is good, it enables us to do some visualization like what I showed you in that example. Isn't it better that we go and change all the visualization, all the relationships to both directional, like changing that, changing this, changing this? If you worked with Power BI in 2015, 2016, even early 2016, Power BI default option was both directional relationship. It wasn't really great, but it was the default option. Those days, actually, consulting on Power BI was really easy. People came and say, well, my model is slow, and we went and see that it is both directional relationship. We changed it to single directional relationship, and it became much faster. This type of relationship comes with a very big price, which is the performance of your model. Now, this is a very simple model with few thousand rows, and I have just both directional relationship between two tables. But in fact, if you start doing that, then, like, for example, one situation would be, well, what if I want to select product line and I want to see count of customers for that product line? Then it means I want to do filtering this way. So let's make this one both directional. Let's make another relationship both directional. After a while, you see that then all of your relationships are both directional. And there are situations that Power BI wouldn't allow you to create all both directional. Just showing you an example of that. Let's say I have a fourth table here. Let's say these two are connected, these two are connected. So basically all of these are connected. Let's say this is a both directional relationship, which is already. This is also a both directional relationship, and this is also a both directional relationship. If this is the case, this relationship would become an inactive relationship. You cannot define it as an active, let aside the both directional relationship itself, right? Because this table already is filtering itself with that kind of relationship. So it brings some kind of like ambiguity in your model that which way the filter is actually propagating. A lot of time that people create inactive relationship, that is due to the number of both directional relationships exist in the model that creates the need of inactive relationship. So I wouldn't recommend that. I wouldn't recommend both directional relationship in your model. There are always, of course, exceptions that you might go and do that. But in general, I would try to do that without both directional relationship. I'm going to show you an example of this without both directional relationship. I'll change this back to single. When I change it back to single directional, you see it is now single directional, filtering only this way. This means our visual wouldn't work correctly again. But what I do this time is that, well, if I want the count of products, I can get that from the table that gets filtered by this customer table. Customer table can already filter the fact table. So if I get the count of product key from the fact table, then I don't really need anything from the product table. And it would be just as simple as that. I can go and bring fact internet sales product key, but instead of the count itself, because I have multiple instances of one product key, I'll get the distinct count of product key, and that gives me the correct result. So without having both directional relationship, I managed to get the result that I want. Now, I'm not saying that always both directional relationship can be solved with this, but this is just a very simple example of that. If you see this 158 and you wonder what this is because it doesn't look like a sum of those, this is actually the total count of products that has been sold. So in fact, we have 606 products, but only 158 of those products have been sold. And this is not, of course, some of those as well, because some of these products have been sold in more than one category. So in each of these categories, we have the distinct count of products sold, and the total number of products sold is 158. So it is working perfectly fine, and I don't need a both directional relationship for that. Some situations you can fix that problem just as simple as this. In some situations you can't, which in those cases you can use some measures using some of the functions in DAX, such as the cross filter functions that can help you to do that relationship in a DAX expression rather than doing it in the relationship itself. Because if you do that in a measure, then you get that performance challenge only when you use that measure. In other parts of your report, it would be fine. Okay, so let's continue on this discussion. So talking about the relationships, this is a recap of relationship, what we have talked about so far. Many-to-many relationship is something that I'm going to explain in a next example. So for now, let's keep on that. Both directional relationship is a relationship that I wouldn't recommend using it. Inactive relationship itself is not a problem, but having an inactive relationship without a measure that actually uses that and say use relationship inside a calculator or something like that wouldn't be really useful. So these are cautions of the relationship. Now that you know the relationship, let's talk about the actual modeling of the tables in Power BI. This is called as dimensional modeling as well. And what I'm about to tell you is not just for Power BI, it is also for like any other BI tools. It is important that you design your table structure in a way that can be reported much better. Let's start with another example. I'll keep this Power BI file open just in case if we have any questions later. I'll create a new Power BI file. And while this is opening, if you have any questions, feel free to unmute and ask questions.
So Reza, with that,
Yes.
Trying to help on the chat window, but we just got one.
Okay.
In normal relational database design, the direction of the relationship goes both ways automatically, right?
I wouldn't use the direction of relationship in a relational database structure as a term, because there is no such term. When you write a SQL script, when you write a select statement, you can join tables in any ways you want. Even if there is no relationships, you can like merge them, join them, inner join, left outer join, right outer join. So that wouldn't really means the direction that we are using here. The direction that we are using here is specifically related to the way that visualization would work based on the concept of that modeling. In relational database, when you design a table, you don't really visualize it to see how that relationship is actually filtering. The relationship in a relational database is for consistency. If I create a relationship between product ID of the product table and product ID of the fact table, I just want to make sure that there is no product ID in the fact table that does not exist in the in the product table, I have the consistency in these two. That is mainly the meaning of that, is not for filtering, versus in Power BI as a visualization and reporting tool, this is used for filtering. I hope that explains.
Right. And just to add something here. So basically, when you use Power BI, you never write queries, right? So if this is the relational database like SQL Server, to get something done, you gotta go and create a query. You have to create all these joins, which means that the assumption is that you know SQL. In Power BI, once you create that model, it looks like the model kind of figures out what it's trying to do thanks to these relationships, right? So the relationships in Power BI are basically promote this ad hoc exploration across tables. But the caveat is that because they're declarative relationships, then you may run into some situations where, they're just not that flexible. And Reza was talking about some scenarios where the model wouldn't know what to do. If you have an ambiguity in the model, in these relationships, then it's going to give up. It's going to say, okay, this relationship is going to cause issue. I'm going to deactivate it. So hopefully that makes. And there's another thing that maybe it might make sense here to talk a little bit about is, why do we need to have multiple tables? This is one of the common questions that I get. Obviously, our life is going to be very simple if we put everything in one table, ask our helpful DBA to give us a query that we just has one table, and then you end up with one data set, basically with one table. So why do we need relationships? What's the advantage for you?
Yep. Very good question. That is leading actually towards this second part of the presentation, which is more about why we create separate tables, how we design them, and why we create a relationship between them instead of one big table including everything. So I'll go through some examples and explaining that, if you don't mind. So let's say in this example, I'll go and get data from an Excel file. Now I should have that Excel file in here. So copying that. Okay, I have 3 tables in this Excel file, but I'm going to just start with one of those tables. Let's say I start with this table, manufacturing. It's a very simple table. It just has a date, the product, and cost. So at this date for this product, this is the cost of manufacturing. Right? Really simple, nothing really special. I load that into Power BI, and I'm going to create a couple of visualizations based on that. For example, just waiting for this to appear. Okay, so for example, one of the things I do is I create a table visual with the product, with the date. Is the product. So product, the date, and the cost. Right? Really simple. Now I'm going to also add a slicer here for the product itself, which means when I select the product, I can filter this table and see records for that product. This works perfectly fine, no problem with that. Now I get a request from 2 other, let's say, team members that, well, we also need to analyze, in addition to manufacturing data, we also need to analyze 2 other data sets, the 2 other tables that I had. In this case, inventory and sales, and they look very much the same, a little bit different field, but mostly the same. They have date and product. In inventory, I also have warehouse and the quantity of each inventory. In sales, I have the product, the date, the quantity, and the revenue, right? So I'm going to add all of these in here into Power BI. I want to analyze these as a data set, right? So if I want to analyze these, for example, I want to be able to select a product in the slicer, and all of these tables get filtered. Just to show you that, I'll create another table visual here for sales, for example, product name, date, quantity, revenue. And let's say one also for the inventory, which is product, date, quantity, and warehouse, right? So what I want to do is to be able to get all of these tables filtered by this slicer. At the moment, only that one, which is coming from the same table, manufacturing, is getting filtered. That is because there's no relationship. So I need to kind of create a relationship between these. For example, I want to say the product here and the product in sales can filter each other. This will create a many-to-many relationship. Many-to-many relationship happens because the product name is not a unique or primary field in any of these tables. There is multiple instances of the same product in manufacturing table and multiple instances of the same product in the sales table. Now, Power BI allows us to create a many-to-many relationship. The many-to-many relationship is by default both directional relationship. That is another challenge that comes with it. And it's not advised to create a many-to-many relationship. But let's say, despite all of these warnings and things like that, I'll create that relationship, right? And then I go and create a relationship with other table based on the product as well, which again create another many-to-many relationship as well, right? So I managed to create these relationships, and they are all many-to-many, both directional. It's not really great, but this model still is not solving the problem that I want. If I select a value in the slicer, it is going to filter them, but here is the problem. Let's look at, for example, one of the products here. In this table, which is the sales table data, I have a product number 20. In the slicer, there is no product number 20. The slicer comes from the manufacturing table. Manufacturing table, for some reason, doesn't have the product 20. Now, if I get the slicer value from sales table, perhaps then it wouldn't include some of other products that includes in the manufacturing, right? So I don't really have a product table that is like my master product table or is my like my product dimension. So I started with this example to explain to you that why multiple tables, why different layout, or back to what Theo suggested as a question, why not everything in one table? In transactional database system, we have a lot of tables. That is one of the let's say, distinguishing features of a transactional database system, that you should have different tables. Each table should be atomic because we have all of these like third normal form, or sometimes you go a little bit further than that as well, to keep your data structure consistent, to reduce the redundancy, increase the consistency, and make your update operation much faster, your insert operation much better. For all of those, there are rules to design a database. And when you design a database, for example, when you have a product table, when you want to create a product category, it is very likely that you move that product category to another table with an ID of that, then you use that ID back in your product table. This is a relational database design. This design, however, wouldn't work ideally for a reporting solution. You need a different design. You need different types of tables. First of all, why you can't bring everything in one table? Because one of the reasons not bringing everything in one table is that you start bringing everything in one table. Let's say you have sales information and product and customer. Then after a while, you realize, well, I want to also add some currency information. You'll bring that into this table as well. Then you realize, well, I want also budget information. Now, the budget information is not at all in the granularity of the sales table. The sales table is like one record per. Thank you. The sales table is one record per, let's say, date, per customer, per product, but then budget is one record per quarter, per salesperson. It's like totally different structure. If you want to bring that into this granularity, it means a lot of, again, redundancy, and much more columns. Every time you want to add something into this analysis, that means expanding your tables. Your tables would be a really big table, wide table, and the analysis of that would be a lot of hard coding. So instead, what we do is we'll bring tables separated, but not exactly separated. Some of them, we join them together, we'll merge them before bringing it. We have two types of tables in this design. Some tables that are used as the values in our visuals, some tables that are used as the slicers, as the axes. In data warehousing concept, we call them, some of the tables are fact tables, some of the tables are dimension tables, and we need a different design for these tables. For example, if I have a chart like this, the fields that are used as the axes, in this case birth date, or in this case yearly income, these are fields that are good candidate to be in a set of tables. We call them dimension tables, or tables that are used for slicing and dicing other tables. Dimension tables are tables that are describing something. For example, it's a descriptive information. You have the age here, you have the name of the customer, first name, last name, phone number, their address, their city, their country. These descriptive information might be text field, but they might be also number fields, for example, age or yearly income. It's a numeric field, but it is still descriptive information. Birth date is a date field, but it is still a descriptive information. A dimension table is a wide table. For customer itself, you can think of a lot of attributes: name, first name, last name, phone number, email address, city, country, commute distance, everything that you can actually gather from that customer as a descriptive information. They are shallow, however. You don't have a customer dimension which is, let's say, 1 billion rows, unless, let's say, you are talking about YouTube or Facebook as a business. For them, the situation would be slightly different, but I'm talking about many other types of examples, more common examples. So these are dimension tables. Dimension table examples are customer, product, promotion. And you see some fields in each of these. For example, in product table, we can have class of product, color of the product, the dealer price of the product, some description about it. For customer table, again, some information for promotion. These are not normally storing a numeric value that needs to be added, or the value in the visual will not be sourced from this. There are some other tables that we keep the values of those tables in those visuals. For example, let's say sales transactions. Sales transaction includes sales amount. Sales amount is the value that I show in the visualization as the line chart itself, as the value of the line, or the column chart itself. We need some tables that keep those numeric information. We call them fact tables. Fact tables explain happening of an action. For example, sales fact table explains that there has been a sales transaction made. That is this row. The values in this table are normally numeric and additive, like order quantity, like sales amount, like discount amount, tax amount. You can aggregate them at the level of let's say month, day, or any of the combinations of the dimensions that you have. Fact tables also have key fields to the dimension table, which normally we call that as a grain of fact table. For example, you might have a fact table with multiple dimension tables, one fact table with just one dimension table. So fact table includes two types of fields. One set of fields are facts, numeric additive. Another set of fields are keys from the dimension tables, and depends on the grain of the fact table, that number of keys might be different. For example, the fact table that I have at the top, the grain for that is 1 record per customer, per date, per product. The fact table, the second fact table, 1 record per product, per customer, per date, per promotion, per sales territory, right? That is the grain of a fact table. The more grain you have, the further detail analysis you can have, but also the bigger your fact table would be in terms of the number of rows. Fact tables are are quite deep. They might be easily over hundreds of millions of records, but they do not have many columns instead. So this concept of fact table and dimension table brings us to a specific design, which the dimension table always have one-to-many relationship to the fact table. Here I have the fact internet sales table. Dim product has one-to-many relationship to this, dim sales territory, dim date, and dim customer. Each of these has a one-to-many relationship to this table. This means the dimensions can filter the data of the fact table. There is a one-to-many relationship, single directional, no need to make it both directional. In fact, this creates a schema, we call it, which is quite common to be called like that in data warehousing scenarios, to be star schema. That fact table is like the heart of star. The points are 2 dimensions. Now, it's not always 5-point star. You might have like one fact table with 1 dimension only. That works fine. Or it might have like 10 dimensions. The fact is that there is one single relationship between each dimension to that fact table. That is what makes it a star schema. If you have a situation like this, for example, that you have, for example, product category, filtering product subcategory filtering product, then product filtering fact internet sales, we don't call this star schema. What we do instead, we combine these 3 as one single product table using SQL join, using Power Query merge statement, whatever that works best for you, and you are more comfortable to do your ETL options for that. When you combine them into one product dimension, then that product dimension filters the fact table just directly. But I wouldn't, for example, combine product dimension with the customer dimension, because there is no meaning to combine these 2 unless there's a sales transaction has made. So in that case, I'll keep the customer table separately and connect that to the fact table. Combining attributes of a dimension table normally is a safe thing to do because you do not add the number of records in your dimension. If I combine category, subcategory to the product, my product table is still the same amount of rows that it has been. It's just add more columns to that. And having more columns make my dimension more powerful because I can slice and dice it, but with one single relationship to the fact table. Having a dimension filtering another dimension is a particular schema. We call it a snowflake schema. You have one dimension filtering another dimension, that filters another dimension, that filters the fact table. This would be a performance killer for a lot of reporting tools, not just for Power BI. That is why it is always recommended to go to more kind of like a star schema route, which you combine dimensions together, which you combine dimension attributes together, have multiple dimensions, and the fact table that gets filtered by these. It doesn't necessarily mean that you have just one fact table. You can have any number of fact tables you want, but the relationship between that dimension to the fact table should be a direct relationship, single, directional, and one-to-many. Now, I'm going to show you how that example can be fixed. Like this is another example of having 2 fact tables. So this is still a star schema. I have fact internet sales, fact reseller sales. They are sharing some dimensions. Product and date, for example, are dimensions that filters both of these, but they also have dimensions that is just for themselves. This is also a star schema. It doesn't mean just one fact table, and it worked perfectly fine. This example I'm going to show you is actually an example of multiple fact table that I'm going to show you. So let's go back to the model that I showed you. So this model, one of the problems of this model is, of course, that many-to-many both directional is a problem, but the main problem is that I don't have a separate product table. I don't have dim product. If I have dim product here, let's say if there is a dim product here, then that table can filter this table, and filter this table. Then I don't really need them to be connected here. Another dimension that I would need is dim date. I'll have date. Then that table can filter this table, filter this table, filter this table. So in fact, I have 3 fact tables. These are actually my fact tables. This is one fact table, another fact table, another fact table, and they are creating 3 stars here. Actually, each star is basically like just 2.1 to product table, another to dimension table. But for example, something like this might have also a relationship to a warehouse separately later, right? That is an example of having multiple fact tables. And I'm going to show you how to do that very quickly because I don't want to go more into like how Power Query works. I'm just creating this situation in Power Query, but you can do that basically in anywhere. I'll delete these relationships. Then I go back, then I go to the transform data. Power Query is a tool like T-SQL or SSIS. You can use it for data transformation. One of the things I want to do is to create a master list of products. The master list of products in this case is going to be a table with including all these products from different tables. I can append these tables like union all in T-SQL. Here we have append instead. If I want to append them, I need to have similar column names for product, at least manufacturing, it is called product, inventory, it is called product, sales, it is called product name. So let's call this product here too. Now I'm going to append these as a new query. 3 or more tables, sales is already there, inventory and manufacturing adding here as well. So this is the appended result. Unlike SQL, in SQL you should have all of your tables should have exactly the same structure when you append it. Here you can append them if they have different structure. The problem is that if there is a field in one of the tables that is not in the other table, the values of that field would be null, right? In this case, I don't really care about those because all I need in this case is just this field. I need product field. So all I can do is just remove other columns. That is my product table, the master list. It, however, includes some duplicate entries. As you can see, I can remove duplicate values by remove duplicates. And this is my product table. Just as simple as that. I'm going to call this product. So this is the product table. It's going to be connected to all of those tables. When I say close and apply, Power BI automatically can find that relationship. If it doesn't, I can just simply go and create that relationship myself. But you see that it created that connection. This then helps me to easily go and use this product table in my slicer. I can go and hide the product column in other tables. I cannot delete them because they are used in the relationship, but I want to hide them because I don't want to use them in the slicer. And this is a great place to do that. You can search for a field here in this section, and I can select all the products that are not in the product table and say is hidden. Is hidden. Makes all of them hidden except the one in the product table. Then I go to my report. I use that product in the slicer here, which actually includes all types of products that can be available, and filtering this would filter all the tables at once. Now this is for the product. Of course, I can do the same thing for the date, but what I wouldn't do is I wouldn't go to here and append them to create a date table. Date table is something you can build by a simple script. I actually have a Power Query script that generates a date table. You can try that whenever you want from my blog. You can actually download it. So what I'll do is I'll create a new blank query. Advanced editor. I'll just paste that Power Query script here. Now this is for 2019 only, so I'm going just to have it from 2019 to 2019. You can choose the from and to date. You can choose what is the first day of the week. You can choose what is your fiscal year start. Lots of configuration you can do that. This script is freely available in my blog. Just search for Power Query date script. And this gives me basically my date table. Closing and applying. This should give me the date field. Of course, if you have a date field in your data warehouse, it would be much simpler. You just use that. Then I create the relationship based on that date field to all of these tables. Now, I think that is why it caused the problem. I have just few rows in this table. That is why it tries to make it automatically one-to-one both directional. But if I make it one-to-many, then it would become active for others as well. Okay, and this one-to-many, single directional. That is just because I have just very few rows in manufacturing that perhaps per day I have one record, and that created this kind of like one-to-one relationship. So here it is. I have one-to-many relationship from the date table to all of these fact tables as well. And then I can use that table. Oh, you have to, again, do that hiding. Always recommended to hide those fields in the other tables that are not your dimension table fields and your value fields. So once I've hide them all, then when I come here, I can create a slicer for the date itself from the date table. And this would also filter all other tables as well. And my data is very narrow range in this. So in general, I created this star schema. Now it might not really look like a star. It's not a 5-point star. It has 3 fact tables in it. It has dimensions, 2 dimensions. You can have more dimensions into that. If you want later on to add warehouse as a dimension, you just bring that as a table connected to this. If manufacturing grows to have another dimension, you create that as well. All of that is simple. I would definitely suggest the date table to be outside of this. I definitely suggest this to be created in Power BI data flows. Then you can reuse it in any Power BI models you have instead of copying and pasting that script, or alternatively have it in your SQL Server database or whatever source you have, and that would give you reusability of that date table, time table, currency table, things like that. I would suggest these to be in a repository that you can use it across multiple places. So the model that I showed you at the end, an example of a good model is this. We have 2 shared dimensions, and those 2 shared dimensions are filtering these 3 fact tables. Very simple. Everything works really nice. The star schema, I would say, is something that you can build a Power BI model without star schema. You can build a Power BI report without creating fact tables, dimension tables. Everything would work, but it wouldn't work in the best way. It's like listening to sitting in a concert and everyone plays their own music. Every table is doing something. They are not in a harmony. That music conductor is the star schema. That's defining the harmony between tables and defining how they talk with each other. That is the star schema. If you design that, then you can get best out of your model. That is regardless of Power BI or whatever technology you are using. That would always help you in your reporting solution. So that was pretty much everything I wanted to tell you. Any questions so far?
Yeah, we have some good ones, and maybe we can start with the. This is a good question also because there are so many things to talk about. So someone is asking, is it valid to have more than one fact table in the model? And I already replied to him, but I will appreciate your opinion as well.
Yeah, definitely. So it is definitely valid to have, like showing you one other example. I'm not going to build that example. I'm just opening the Power BI so that you can see it actually. One very common example of that is budget versus actual. Let's say you have your actual sales coming in and then you want to compare it with the quota that you had or with the budget that you had. If you don't have these at the same model, then how you are going to analyze it? And these two tables might be in totally two different granularity. So if I go to the model here, just making it fit in one page, a bit bigger. Okay, here I have fact reseller sales. The sales consider actual or coming year, and sales quota is here. These are two different fact tables. I cannot combine them because this table is on a daily basis. This table is on a quarterly basis. For example, for each employee, we said that in this quarter, their sales quota is this. And then the actual tells us that how much actually they sell. So we need to kind of like analyze these together and see, are they meeting the quota or not? It's not always the situation that you combine that and bring it to here, because this fact sales quota might be related to another dimension here that this doesn't support. So different granularity is a good reason that you can have different fact tables in a model, and it happens very common.
Right, and something to add here is that, remember, Microsoft is giving you here a technology which is very powerful. This is the same technology that professionals use to build semantic models, organizational semantic models on top of things like data marts and data warehouse. So when you start, one of the most common issues that I see when I go to clients and when I teach Power BI is that business users, because they are not trained into data warehousing or star schemas and all of this, they approach every report as a brand new thing. So here's my report, here is the fields, let's go and have a data set for it. So I have a report that does something else a little bit different, and let's go and have a data set for it. If you take this path, there is nothing, probably your reports are going to work, but you're going to be in so much pain to maintain all of these data sets for all of these reports. So instead, if you take the mentality, I'm going to approach this from a different angle. I'm going to say, I'm a sales guy, or I'm a marketing person, I'm a business person, I know my subject area. I'm going to try to build a model that represents that subject area. So I know I have a list of products, I have a list of customers, I have sales. Those are the entities that I care about. Well, let's go then and create this schema that Reza was talking about. And at some point, like he said, typically we'll have a scenario where you need to add a budget. You started with actual. Your boss gonna like it so much, gonna say, now let's compare actual with the budget. If you start with this assumption, if you start with a good foundation of building a model, maybe just one model, but many reports on top of it, it can become a very powerful and flexible thing. You can keep on adding things to it. And by all means, it's actually very common a model to have multiple fact tables and multiple dimension tables. So you can keep on extending it in time, and it will be a great thing. So
thank you.
And the second question here was, if you are lucky to build it on top of, this is actually my reply. When you load data into a model, should it already be in a fact dim table design? In other words, should it be already in a star schema design? And I already replied to that person, but I would like to get your opinion as well.
Yeah, that is a good question. That actually depends on what you are going to build. Let's say I'm building a proof of concept with Power BI, right? If I'm building a proof of concept with Power BI, perhaps my data is coming from a transactional data source. It might even come from an Excel file or something like that. I don't have an actual data warehouse to populate data from it, to build my fact table, dimension table in there, and then populate it from there into Power BI. So I'll do that everything in Power BI. I'll use Power Query data flows to just build that dimension, fact table design, star schema design, and visualize it. But if I'm looking at a much bigger scale, enterprise scale, longer term project, then ideally, yes, we need to have a data warehouse, a place that these tables are designed like fact table, dimension table in there. Now, where that data warehouse lives or what technology you use, that really depends on the project scale and what like licensing and many other factors. Some might use Azure SQL Database, some might use SQL Database on premises, some might use Power BI data flows for that. It doesn't really matter what is your repository for a data warehouse, but that place is highly recommended to build that structure and then feed that data into here. The way that you build that structure is also, again, depends on many factors. You might prefer to use SSIS as your data factory to do that transformation. It might be just Power Query in Dataflow to do that transformation. Whatever you use, ideally, you need to have data built in that way to bring it into Power BI.
Right. So typically what what comes before Power BI is the data integration. Based on what I've seen in my practice, data integration is probably the most difficult thing you have to tackle. It's not uncommon for a company to have multiple systems, multiple ERP systems through acquisitions and things like this. So another big problem that I see is that people get so much excited about Power BI and then they say, I'm going to do a shortcut here. I'm going to actually try to load the data from different systems in Power BI, and I'm going to do modeling in there. And sooner or later, this approach doesn't work very well. So for most companies, it makes sense to stage that data into a relational database from different places. That will require obviously a little bit more effort and stuff like that. But the advantages down the road are going to be much better because you're going to have a system, you're going to store that data in a system that is designed for that. You can overcome performance issues and stuff like that. So for most people, although it looks like the industry is kind of advocating, okay, nobody has time for this, let's go and do self-service BI. Well, if you do a self-service BI, just like everything else in life, when you try to take shortcuts, sooner or later, you may actually pay the price, and the price typically is performance, flexibility, because business is just, the data itself is more complex than trying directly to suck it into Power BI. That's one thing I want to mention. And then let's see what we have. Okay, here's another good question. How many tables does a typical model consist of? 5, 10, etc. So that's another very good question, Reza. I'm gonna let you go first, and then I'll add something to it as well.
Yeah, I would say it might start with 5, 10, but a real world model would have much more than this, because you start with an area and then you combine it with other areas. Let's say you start with sales analysis, that becomes, let's say, your sales table, your fact sales table, your customer dimension, product dimension, date dimension. This can be easily 5, 6, even sometimes 10 tables. But then later on, you'll bring inventory in this as well. Now, there are two approaches. Theo mentioned that as well. One approach is that you may say, I'll create totally different Power BI file for inventory. But another approach is that in the future, you might consider some kind of dashboards that has sales and inventory both filtering by the same dimension. So you might consider bringing that into the same model, and that gradually increase the size of your model. It is quite possible that you have a model with many tables, but the factor is that you need to design it in a good way. Having many tables is not a problem, but having not good design, even if you have 4 tables, is a problem.
Exactly. That was a great summary. Thank you, Reza. So just something to add to it. This is a very hotly debated question. So in fact, I myself sometimes, it's difficult to put the boundary. How would you separate this semantic model? And one thing that you have to keep in mind is the moment you decide to split them apart. Let's say, as Reza said, this is going to be my sales, and I'm going to start on inventory, and I'm going to create an inventory model. Well, what about if your boss comes and say, I want to have in this single visual, I want to be able to analyze a measure from one subject area and a measure from another subject area on the same visual, maybe to do some trend analysis, kind of compare them side by side. So if you split them into separate into separate models, then essentially you won't be able to meet that requirement because these models are going to be like different entities, basically different islands. You won't be able to connect them with each other. That's why, although there are so many factors such as ownership, performance, security, who's going to be owning what, and who is going to be basically maintaining all of this stuff. My recommendation would be see if you can capitalize on a single model, kind of enhance it on time, in time. Maybe start with sales, then they want to do inventory, maybe add inventory. That model is going to get bigger, but that's okay. Even if you split it into separate models, it's going to be big too. And the other thing is that when you start splitting those things, then you're probably going to be duplicating things. So my product dimension, my customer dimension, what's going to happen with that? More than likely, every model is going to have their own copies of these dimensions. So that increases your maintenance, increases the size of the model. So the approach that I take is that can I actually address the requirements with a single semantic model? And if I face a situation where it's not possible, for example, there are some sensitive measures and only certain people need to have access to this, they have to be physically separated by anything else, well, that'll be a good reason to actually split into a separate semantic model, if that makes sense.
Thank you, Theo.
Any other questions? It looks like we are pretty much, we don't have any more questions. Anything else? You can unmute yourself. We have a few more minutes. Well, it looks like that's going to be the end of it. Reza, thank you so much. It was a great presentation.
Thank you for the opportunity.
We'll have you again for sure. Thank you for joining all the way from New Zealand.
Thank you.
And
Hopefully
it looks
next
like
time.
next time is going to be, but it looks like the time difference actually work out well for you because you're in the morning, we are late at night, so that worked out pretty well. So guys, please give me a couple of hours to get the video, the recording uploaded into that site that I sent before. And I'm looking forward to meeting you on November 1st. Take care.
Thank you. Bye, everyone.
Bye-bye.